Alright, in our homework we have a problem that looks similar to this, and I'm going to make a video here to kind of help you through it. It does have a square root in it, and remember that when we are taking a derivative, the first thing that we do when we see a square root is to write it as a function raised to a higher power. So the first thing I'm going to do is I'm going to take what we have there and I'm going to rewrite it as x equals I'm going to put parentheses 144 minus p, and instead of writing square root, I'm going to write all of that to the 1/2 power. All right. So I'm going to give you, remember, I'm going to give you the formula for the elasticity function, and all you have to do is know how to use it. So remember, negative p is going to be there, so we're just going to write negative p. We do want to divide by the original function, so I'll just go ahead and put that right down at the bottom, just as is with the 1/2 power. But the only thing we have to do is then we have to find the derivative of p of f of p there, which is right here, 144 minus p to the 1/2 power. Of course, we're going to have to use the chain rule since everything is being raised to a higher power. So that would be 1/2, bring that down to the front, times we're going to write the inside function as is, and then we're going to reduce the power by 1, so we're going to raise that to the negative 1/2 power. And then we're going to take the derivative of the inside, and the derivative of 144 minus p would be negative 1, kind of treating that p like we would treat x. Okay, now we're going to simplify it because we're going to use it to put some values into it. So I'm going to do a couple of things here. First of all, I have a negative times a negative, so I'm going to go ahead and just make that a positive p. And we have a 1/2. I'm just going to go ahead and write that 1/2 right there, just to bring it out. And since you have all of this raised to the negative 1/2 power, I'm going to bring it down and make it a positive 1/2 power. Okay, so that disappears from the top. Now, one thing that we want to keep in mind, if I have, this is a square root, so let's think about this like this. Square root of 144 minus p times the square root of 144 minus p. When I have a square root, and two square roots multiplied together that are exactly the same, basically the square roots end up canceling each other out. So we end up with something actually pretty simple. We end up with 1/2 p divided by 144 minus p. And that's a much simpler formula than the one that we started out with. So the first step in doing this problem is to be able to come up with the elasticity of demand function yourself, using the formula that is provided for you, and being able to simplify it to make it a lot easier to use. So now we're asked to plug in some values into that function. So 118. Okay, this might be a different number than the one that you have, but I'm going to show you with the problems that I'm given in my list. So 144 minus 118. Okay, so now all you have to do is put that into your calculator. So 1/2 of 118. Okay, and I get 59. And then we're going to divide that by 144 minus 118, and I get 26. 59 divided by 26 gives me 2.269, which you can tell here they rounded to 2.27. Okay. Now we want to keep in mind about if our function gives us a value that is greater than 1. So if that elasticity function, that elasticity of demand function gives you a value that's greater than 1, then we say that the demand is elastic. Remember what we said was the demand decreases when the price rises. So you raise the price by 1%, the demand decreases by 2.29%. So the demand is decreasing by a greater amount than what we are comfortable with by just raising the price 1%. So this means that your customers are very price sensitive, and you raising your price is going to decrease the demand by a lot more than what you want. It's going to actually cause your revenue, okay, it's going to cause your revenue then to go down. So you're losing a lot of customers by raising your price, and you don't want to do that. So revenue is going down, and when our customers are very price sensitive, then we say that the demand is elastic. All right. So let's see what happens when we put in a 96. So E of 96, that would be 1/2 of 96 divided by 144 minus 96. So we're going to take 96 divided by 2. I get 48. And then 144, take away 96, I get 48. And in this case, I get exactly 1. So remember that every value that we get out of our elasticity of demand function, we're comparing it to 1. Is it greater than 1? Is it equal to 1? Or is it less than 1? So in this case, if it's directly equal to 1, then we say that the demand is unitary, meaning this is the ideal price that I can charge, and that it's going to actually maximize the revenue that I can get from my customers. So if I charge that price, then I want to leave my price exactly at that, because that is the maximum revenue that I'm going to get out of my customers. Okay, so the last one here, we're going to take our elasticity of demand function and put in 66. Oops. So half of 66, we end up with 33. 144 minus 66, I end up with 78. 33 divided by 78, I end up with 0.42. All right, so if my elasticity of demand function gives me a value that is less than 1, then our demand, we call that inelastic. So remember, the idea here is that if I raise my price by 1%, I'm only going to lose 0.42% in the demand. So the demand's going to decrease, we said, but it's only going to go down by 0.42%, which is perfectly acceptable. My revenue is actually going to go up because I'm not going to lose that many customers. And in fact, the price that I raise this to, so if I raise the price by 1%, I only lose a little bit of customers, so therefore the price that I charge, that price increase will be worth it to me, because overall, in the end, my revenue will actually increase. All right, so there's some ideas there with problem number 10 from your homework.